Good morning friends. Today we will discuss about the hybridization of organic molecule. Hybridization of organic molecule. This is the last discussion about the hybridization. So we can call this is the hybridization part 3. This is methane molecule. This is methane molecule is a saturated hydrocarbon. Here this carbon is surrounded by 4 number of sigma bond, so it is the hybridization of sp3. Unsaturated hydrocarbon is alkene and alkyne. So here we will discuss about the ethene molecule. It has 2 carbon, and in between the 2 carbon here 2 bonds, one is sigma and other is pi. So here each carbon is surrounded by 3 number of sigma bond, so the hybridization will be sp2. Here also the carbon has hybridization sp2. If we discuss about the propene molecule, prop 1 in, this is prop 1 in, so we will satisfy with the hydrogen, the shape of the molecule will be like that. Now this carbon is surrounded by how many sigma bond? One sigma bond. In between the 2 carbon there are 2 bonds, one is sigma and other is pi. So in total this carbon is surrounded by 3 number of sigma bonds, so the hybridization will be sp2. Here also this carbon is surrounded by 3 sigma bonds, so the hybridization will be sp2. But here this carbon is surrounded by 4 number of sigma bonds, so the hybridization will be sp3. Now we'll discuss about the some haloalkanes like chloroethane. This is the structure of chloroethane. Now we'll assign the hybridization of these 2 carbon. This carbon is surrounded by 4 number of sigma bond, so the hybridization will be sp3. Here also this carbon is surrounded by 4 number of sigma bond, so the hybridization will be sp3. This is the structure of ethanol molecule. Here this we will discuss about this carbon. Here it is surrounded by 4 number of sigma bond, so the hybridization will be sp3, and it is also surrounded by 4 number of sigma bond, so the hybridization will be sp3. Some aldehyde molecules, for instance propanaldehyde has 3 carbon in its chain. So we will now satisfy this carbon with the hydrogen. This is the propanaldehyde molecule. Its IPSC name is propan 1-al. We will discuss about the IPSC name in some other lectures. Here we have to assign the hybridization of these carbon atoms. Here this carbon is surrounded by 4 number of sigma bonds, so it is the hybridization sp3. Here also this carbon is surrounded by 4 number of sigma bond, so the hybridization will be sp3. Now we see this carbon. Now this carbon is surrounded by 1 sigma bond, this is 2 sigma bond. Now in between the carbon and oxygen there are 2 bonds, one is sigma bond, one is pi bonds, because when more than 1 bonds are present, one will be sigma and others will be pi. So here 2 bonds, one will be sigma and other is pi. So this carbon is total surrounded by 3 number of sigma bond, so the hybridization will be sp2. So you see the difference. Here one carbon is sp3, this carbon is sp3, and this carbon is sp2. Now some alene molecules will pick. This is the structure of alene molecule. Here you see the hybridizations. Here this carbon is surrounded by 1 sigma bond, and in between the 2 carbon there are 2 bonds, so one is sigma, so there is pi. So this carbon is hybridization is 3 sigma bonds, so the hybridization will be sp2. Now this carbon here 1 sigma 1 pi, so in total this carbon is surrounded by only 2 number of sigma bonds, so the hybridization will be sp. Here the same thing like this, so this hybridization will be sp2. Now we'll discuss about some benzene molecule. This is the structure of benzene molecule. Here in each center there is one carbon. Each carbon is attached to some hydrogen, because carbon has to make 4 bonds, 1 2 3 4, 1 2 3 4, 1 2 3 4. So here in which every carbon there is attached some hydrogen. So each carbon has the hybridization here 1 2 3 sigma bond, 1 sigma bond, 2 sigma bond, 3 sigma bond, and in between the two carbon 1 sigma, other is pi. So in total this carbon is surrounded by 1 2 3 number of sigma bonds, 3 number of sigma bond. So the hybridization will be sp2. So the hybridization will be sp2. Here every carbon is like that, so every carbon is sp2 hybridized, sp2 hybridized. Now we will discuss about some cyclohexane molecule. Cyclohexane, here it is one carbon. Now here each carbon is attached to each 2 number of hydrogen bonds, 2 number of hydrogen bonds. So if we will now count the number of sigma bonds, 1 2 3 4. Here every carbon is surrounded by 4 number of sigma bonds. So here each carbon has the hybridization sp3. Some ether molecule like diethyl ether, diethyl ether. This is the structure of diethyl ether. Now in diethyl ether there are 4 carbon will satisfy with the hydrogen. Now we'll speak about the hybridization. Here every carbon is surrounded by 4 number of sigma bond. So the hybridization will be sp3 for each carbon. So here this is also sp3, and this is also sp3, and this is also sp3. Now if we will discuss about the hybridization of oxygen, you see there are 2 sigma bonds, and in oxygen there are 2 lone pair. So whenever we will discuss about the hybridizations, we have to concentrate on the number of sigma bonds and the number of lone pairs, not the pi bond. Here 2 sigma bond, 2 lone pair over the oxygen, so in total 4. So oxygen also has the hybridization of sp3. So here all the atoms have hybridization sp3. So this is all about the some organic molecules which is hybridization I discussed. This is the last lecture of hybridizations. In the next lecture we will discuss about some shape and how to draw the shape of the organic molecules, and inorganic molecules we will discuss. So goodbye.